All right, let's jump right into it. Picture this. The year is 1984. We're at the annual meeting of the American Association for Artificial Intelligence, and the atmosphere in the room is just incredibly tense. Two absolute pioneers of the field, Roger Schenck and Marvin Minsky, step up to a public debate, and they drop a total bombshell on the business community. They essentially prophesied that the skyrocketing enthusiasm for artificial intelligence was spiraling dangerously out of control. In their eyes, the whole industry was heading straight for a catastrophic nuclear winter. So to really understand this dramatic warning, we have to trace this technology's history. Because you see, AI isn't just some straight upward line of constant progress. Not at all. It's actually been shaped by these recurring boom and bust cycles. We're talking dramatic seasons of boundless sky-high optimism, inevitably followed by crushing disappointment and frozen funding. And honestly, understanding these historical seasons is absolutely crucial if we want to make sense of the AI landscape we're all living in today. So here's our roadmap for this explainer. 1. The era of high optimism. 2. The first AI winter. 3. AI becomes a business. 4. The second AI winter. And 5. The seasonal nature of AI. Starting with Section 1, the era of high optimism, the seeds of spring. Everything officially kicked off in 1956 at the now legendary Dartmouth Workshop. And what followed in the 1960s was just a massive, massive influx of government money. We're talking millions of dollars flowing out of DARPA in the United States, handed over to researchers with practically no strings attached. It created this era of boundlessly naive optimism. I mean, the early pioneers genuinely believed that human-level intelligence was literally just around the corner. But as we'll see, this early spring was destined to hit a hard freeze by 1974, thaw out again around 1980, and then completely crash once more in 1987. So what did that first spring actually look like on the ground? Well, the term artificial intelligence itself was coined by John McCarthy at that 56 Dartmouth Workshop. And with all that DARPA funding flowing so freely, the field just blossomed. By 1966, you had Eliza, which was effectively the world's very first chatbot. Fast forward to 1969, and we get Shaky, a pioneering early mobile robot. And right alongside all of this, driven entirely by Cold War urgency, the government was aggressively funding machine translation initiatives. The dream was to instantly translate Russian scientific and intelligence documents into English. Progress just felt completely unstoppable. And nothing captures the sheer hubris of this era quite like this quote from Nobel laureate and AI pioneer Herbert Simon in 1965. He said, "In 20 years, machines will do whatever a human can do." I mean, wow, it was a wildly confident prediction, but it was exactly this kind of dangerous overpromising that set the stage for a spectacular crash. Researchers were writing these proposals literally promising the moon, and when they couldn't actually deliver, the patience of their funders completely ran out. Which brings us to Section 2, the first AI winter, the deep freeze of the 1970s. Now, let's nail down exactly what an AI winter actually is. Think of it like shifting weather patterns. An AI winter is a distinct historical period marked by heavily reduced funding and a massive drop in interest in artificial intelligence research. It really operates like clockwork. First, you get this massive hype cycle full of huge promises. Then, the technology inevitably fails to live up to the hype, which sparks fierce criticism, and finally, the money just dries up entirely. I absolutely love this example because it hits the nail on the head regarding why all that hype collapsed. Remember those Cold War machine translation projects we just talked about? Yeah, they were a catastrophic failure. Researchers vastly underestimated the sheer complexity of what they called common sense knowledge and word sense disambiguation. There's this famous, albeit slightly apocryphal example from the time that perfectly highlights this. They supposedly tried to translate the phrase, "the spirit is willing but the flesh is weak," from English into Russian and then back into English again. The machine spat out, "the vodka is good but the meat is rotten." It's hilarious, but it proved a massive point. The machines had absolutely no idea what those sentences were actually about. They had zero context. So, the failures became just too obvious to ignore. In 1966, the LPAC report brutally exposed the total lack of progress in machine translation. Then, over in the UK in 1973, the Lighthill report basically came out and said that AI just couldn't overcome the combinatorial explosion of real-world problems. That single report led to the near-total dismantling of AI research across the UK. And back in the US, a very frustrated DARPA, tired of the unfulfilled promises and the exaggerated claims, drastically slashed its academic funding. Just like that, the first winter had arrived. Moving into Section 3, AI becomes a business, a false spring in the 1980s. So what actually managed to thaw out the industry? Well, it wasn't the pursuit of human-like general intelligence, that's for sure. It was actually something highly specific, called an expert system. Simply put, an expert system is a program that mimics the decision-making process of a human specialist. Instead of trying to build an entire brain, researchers realized, hey, we can just bottle up human expertise into practical, narrowly focused software and sell it for commercial use. The architecture behind these systems was actually brilliant, but pretty straightforward. Step 1 was building the knowledge base. You'd interview human experts like doctors or engineers and painstakingly encode their knowledge into hundreds, sometimes thousands of if-then rules. Step 2 was the inference engine. This was the software that chained all those rules together to actually reach a logical conclusion. A famous academic example of this was Mycin. It used this massive web of rules to diagnose bacterial infections and recommend antibiotics, and it actually matched the accuracy of human specialists a lot of the time. And if you're wondering why the 1980s business world went completely nuts for this tech, well, $40 million. That is the estimated amount of money that the Digital Equipment Corporation, or DEC, saved every single year by using an expert system called XCON. XCON configured complex orders for mini-computers, which avoided massive human errors and saved a ton on labor costs. This one single number proved to everyone that AI had immense commercial viability. It wasn't just a lab experiment anymore. It was a hardcore, cost-saving business tool. Thanks to massive wins like XCON, the AI industry absolutely exploded. We went from a market of just a few $1 million in 1980 to a $1 billion market by the late 80s. At one point, 2/3 of the Fortune 500 were using some form of expert system. But you know what really poured gasoline on this fire? Geopolitical panic. In 1982, Japan launched this massive fifth-generation computer project aimed at building advanced reasoning machines. Terrified of falling behind, Western governments from the US to the UK unleashed an absolute torrent of funding right back into the field. Which sets the stage for Section 4, the second AI winter, the bubble bursts. So what went wrong this time around? Well, massive cracks started showing in these expert systems. First up was the knowledge acquisition bottleneck. Turns out, extracting rules from human experts is incredibly tedious, and a lot of times humans can't even articulate exactly how they make their intuitive decisions. Second was brittleness. These systems had absolutely zero common sense. If a problem fell even slightly outside their hand-coded rules, they failed completely and unpredictably. Third, maintenance became a total nightmare. As these databases grew to thousands of rules, contradictions started creeping in. Basically, hand-coded symbolic AI just couldn't scale to handle the messiness of the real world. But the real final nail in the coffin was the hardware. See, a lot of these expert systems required incredibly expensive, highly specialized computers known as Lisp machines. And by 1987, standard general-purpose desktop computers had gotten so powerful and so cheap that they just completely undercut the entire Lisp market. The hardware market collapsed, specialized companies went bankrupt, Japan's fifth-generation project quietly wound down, and the funding completely dried up yet again. The second catastrophic loss of faith had officially arrived. Finally, Section 5, the seasonal nature of AI, from Dartmouth to today. When AI finally started to thaw out again in the 1990s and 2000s, it only survived by completely abandoning those old methods. The field evolved away from those fragile, manually encoded if-then rules of the 1980s and shifted heavily into modern machine learning. You see, today's large language models basically solved that old knowledge bottleneck that killed the expert systems. Instead of having a human painfully write down every single rule one by one, today's AI learns patterns organically by absorbing expertise directly from massive data sets. But, as we look around today at the billions of dollars pouring into this current AI era, what a lot of people are calling the new AI spring or the AI boom, we really have to look back at the 1960s and the 1980s, because history clearly shows us that every single era of massive funding and sky-high promises has eventually slammed into the harsh reality of technological limitations. So I want to leave you with this final, lingering thought based on everything we've unpacked in this explainer today. Have the fundamental breakthroughs of machine learning finally allowed us to escape the AI winter for good? Or is history just preparing to repeat itself with a brand new freeze waiting just around the corner? Keep questioning and keep learning.